Hello and welcome. I'm Rex Basserfield and this is a video about my Quilcom SIM-GONG. The SIM-GONG doesn't make use of any samples, rather it's a synthesizer designed to make various gong-like sounds. As such, it may not be sounding so authentic, but it gives you a lot of possibilities to make adjustments to the timbre and the behaviour. The system is a little bit more complex than my other Sim series plugins because I wanted to be able to provide an engine that could simulate various types of gongs. So we have the Chinese or Chow gong, nipple gong, sometimes called the boss gong, but I prefer the term nipple to be honest. Wind gong, or lion gong, or feng gong. An opera up or opera down, which changes its pitch if you strike it hard. And a singing bowl gong. And also there are various other strange variations which you might find interesting to listen to. The sound of a classic chow gong or tam tam in an orchestra is very difficult to synthesize, and I tried various methods and I came up with the one used here. This breaks down the sonic elements into two components. One is the tones, where you can make out audible tones, sort of, and a chaotic sound, which is consisting of much higher partials which are progressively excited after the main strike. In addition to the tones and the chaos, I provided the swing section, and this aims to simulate really it's more applicable to larger gongs, which when they're struck hard swing backwards and forwards at quite a low rate. So in effect these are two more or less separate synthesizers, although there is some interaction between them. The chaos is monophonic, so if you have a chaotic sound selected you can only play on middle C, which it says there. And the B below middle C in all cases is a damping key switch which is velocity sensitive. So if I make the gong sound, then I press B, the sound is damped according to how hard I hit the key. This is going to be hard, in which case it's damped immediately, and if I hit it softly, then you get a slow decline in the sound as it's damped more slowly. Now if we turn chaos off, we can play from middle C and up 3 octaves. So if I find a preset which I think uses that, nipple gong 3, we see chaos is off and we can play polyphonically and chromatically from middle C up for 3 octaves. So if I turn the chaos off now, then we can talk about the tones synthesizer. We have mallet hardness, which goes from hard to medium to soft. And of course the decay time. Most gongs are percussive in nature, so we leave this set to strike. But if we go to sing, we can simulate a singing bowl. So this is just the regular bowl which we strike. And if we wanted to sing, let's go to singing bowl, then the system changes and we have a sustain function. So if we hold the key down, the velocity affects the volume and tone, and when we hold the key down, the sound builds like this. So I'm pressing, holding and releasing a key to make the singing sound. Now, as you can see here, there are up to 8 modes available where you can set the frequency ratios. But on a real gong, especially the larger gongs, the amplitude of these modes will fade in and out. So the vary control sets the amount of this fading in and out. So let's make it extreme. And the actual rate of each individual LFO is different, but the overall average rate is determined by the decay length. So a longer decay will give a slower variation. That's an extreme setting. The first half of the knob is fairly subtle, which is the area for the best simulation. Now, of course, you can set the frequency ratio of these modes individually, or you can click on a default. And what I found good fun and quite interesting is to keep pressing the random button until I get a sound that appeals. Now, you don't always need 8 modes. Bells, for instance, often use maybe 3 or 4 modes. So here we can change the complexity, which reduces by crossfading the amount of modes involved. So if I set up a long decay time, that's how we can use the complexity knob. The tones synthesizer uses 2 different models, and this is normal additive synthesis, by the way. The wave shape changes with velocity and so on. So the 2 models you can mix between using the model knob. We have a high pass filter which can reduce the lower frequency elements. Now the low pass filter control sets the minimum value frequency of the low pass filter, which has quite a steep slope, and when you strike a note harder, the filter opens up a little bit beyond this base value that you've set here. High velocity now. So that's the tones synthesizer dealt with. So now I shall go on to the chaos synthesizer. So when we turn the chaos synth on, we can only play on middle C, as I mentioned before. This system uses another 8 different frequency ratios that we can set, but this time it's for resonant comb filters. The build knob sets a sort of rate at which the filter opens up to provide the crescendo. So the default, if you double click, is 2 seconds. And I'm using the B key there to quench the sound. So let's set a much longer build time. Shorter one. You can even set it to instantaneous, which is rather different. The decay knob sets the decay, the amplitude decay of the chaotic sound. Now, since this is a monophonic synthesizer, the pitch, the basic pitch for all these comb filters is set with a knob rather than taking a value from the MIDI keyboard, since it only functions on middle C. And it's important to remember that this being a separate synthesizer, it's up to you to match the sound of the chaos to the sound of the tones. Otherwise it's going to sound like a cymbal that's been welded onto a tubular bell or something like that, which may be what you want, I don't know. Now we have the same kind of arrangement on the chaos filter values as we have on the mode frequencies here. So we can set random tones. And we can set default comb filter frequencies. Or random ones. And the complexity control works in a similar way. Now, of course, these comb filters are resonant, so we have a resonance control. When it's fully down, it's more or less white noise. It's actually 2 sources of velvet noise. And we can increase the resonance to make the sound more metallic. Until we go extreme. we have a high pass filter which works similar to the one on the tones. Now the low pass filter is very important in the sound of the chaos. This is what we open up with the build system, which is an accumulating envelope generator. So set on minimum, this is the base setting, so we have to strike the note repetitively and quite hard to get the filter to open up. But if we increase that setting, then the bass level comes up and we can open the filter more easily. So this is arguably one of the most important knobs on the Chaos synthesizer. Now on the audio panel we have a mix knob, and this mixes blends between the tones and the chaos. And the stereo with control, of course. The swing panel, which we don't have to use, but let's turn it on. The first half of this control is more useful for the subtle sounds, but I'll turn it up so you can hear the more extreme effect. The pitch panel is where you set the bass pitch when you play middle C, and also we have a built-in pitch bender which I calibrated against YouTube videos. So you have for opera up, and opera down. Now, as per usual, there's a lot more information in my user guide for this, and also some stuff in the background info folder. So I hope you can make some use of this rather odd synthesizer. I'm going to play you out with a selection of 6 preset sounds, less usual ones, and until the next time, bye!